Welcome again to Advanced Functions, Polynomial Functions unit. In this lesson number 5, we're going to learn two ways to divide polynomials. First method, we're going to take a look at a long division. And the second method, we're going to use a synthetic division. First, we want to understand the division of natural numbers. So we did this when we were in elementary school, where we have to do a long division. So instead of using a calculator, let's do a 57 divided by 8. So as you can see, 8 doesn't go into 5 for the first digit. So then you wonder, how many times would 8 go into 57 at most? It would be 7. So 8 times 7 is 56. And then the remainder is 1. So I'm going to stop it here. I'm not going to go further into getting a decimal. But the big idea of dividing polynomial is we're going to use exactly the same method as a long division. So in this case, 7 is the quotient and 1 is the remainder. And 57 is, we call it a dividend. And 8 is a divisor. So let's take a look at it more closely. So long division, so we have two polynomials, and these two polynomials, they're unique polynomials Q and R, such that this is called a division statement. And there's two ways to represent division statement. Number 1 or number 2. It's exactly the same thing. The difference is that each left side and right side, it has been multiplied by d of x. So that's why when I multiply d of x to the left side and right side, it cancels out. But then you have d of x at times q of x. So this is the most common method that everyone represents using a division statement. Now, keep in mind that the degree of the remainder has to be greater than or equal to 0, but less than the divisor. Again, so let's take a look at the acronym. So capital D and small letter d is totally different. So capital D is called a dividend. Small d is a divisor, what you're dividing it by. Q is the quotient, your answer, and R is the remainder. Now, if the remainder is equal to 0, it means two things. It means that dividend is divisible by divisor perfectly. And another way to represent is that divisor is a factor of dividend. So we will be using this further later in the chapter called a factor theorem. So long division is quite useful to figure out the quotient and remainder and whether or not the divisor is divisible by the dividend. I mean, if the dividend is divisible by divisor. So let's practice. First things first, we are going to align them in order, in decreasing order in terms of exponent. So we can double check. The exponent is 3, 2, 1, and 0. Okay, so then that is especially important for dividend. So 6x cubic minus 4x squared minus 9x minus 3. Now, unfortunately for this one, it has a degree of 2 and then it's missing degree of 1. So what I would recommend is you will fill it in. So 2x squared plus 0x minus 3. Okay, so it will help you in a long run. So let's try this. So first thing, look at the degree. So 6x3 and 2x squared. So 6x cubic divided by 2x squared. So that will give me, in terms of coefficient, 3x. Now you're going to align them where the degree x is. It's over here. So I'm going to write 3x. Okay, so then 3x, so we're going to do the distributive property. So 3x times 2x squared gives me 6x cubic. And then 3x times 0x is going to give me plus 0x squared. And 3x times negative 3 is going to give me negative 9x. And then, as always, we are going to subtract it. Okay, always subtract as you go down the long division. So this cancels out. And negative 4 minus 0x squared will give me negative 4x squared. And negative 9x minus minus, so it becomes positive, so it cancels out. And then you're going to bring down 3, negative 3. So we're missing a degree here, right? So we're going to fill it in. Always fill in a degree if it's missing. Plus 0x. Again, so you're going to take a look at the first term and the first term over here. So negative 4x squared divided by 2x squared. So that will give me negative 2. So now after you figured out what is divisible by, we're going to do the distributive property with the quotient and the divisor. So negative 2 times 2x squared is going to be negative 4x squared. Negative 2 times 0x is going to give me plus 0x. And then negative 2 times negative 3 is going to give me positive 6. So therefore, negative 4 minus negative 4x, right? So you're going to subtract always. So they cancels out. And then 0, 0 cancel out. And negative 3 minus positive 6 is going to give me minus 9. Okay, so we found everything here. So let's identify. So this 3x minus 2 is the quotient. Negative 9 is the remainder. This is a divisor. And under this division is a dividend. So let's put it in a division statement. So reminder, division statement looks like this. Divisor plus remainder. So dividend, which is 6x cubic minus 4x squared minus 9x minus 3 is equal to quotient, which is 3x minus 2, times a divisor, 2x squared minus 3. So when I'm filling it in, I'm going to ignore any fill-in exponent or zeros that I plugged in. So do you see this when I plugged it in when I'm doing long division? But when you're writing the statement, you don't have to include it. And then plus the remainder, which is negative 9. So this is my division statement when you do a long division. Okay, so it means that when you multiply this 2 and minus 9, you're going to get a dividend. So let's try second one. Again, so we have x cubic. Again, it's missing, the degree is missing. So it's missing 0x squared, also 0x, and then plus 1. It should always go in decreasing order by 1 degree. And then x plus 1. So first x cubic divided by x. Then it's going to be x squared. So x squared, I'm going to align it where it's located. So it's x squared. And do a distributive property. x squared times x gives me x cubic. X squared plus 1 gives me plus 1 x squared. Okay, we're going to subtract. So they cancel out. So it's going to be negative x squared. And then that's it. So what you're going to do is bring it down. Plus 0x. Now, negative x squared divided by x, always the first term. Negative x. So then do the distributive property, negative x squared minus x. And then we're going to subtract this whole thing. So be careful with the sign. Negative minus negative becomes positive, so they cancel out. 0x minus negative x, minus minus become positive, so it's positive x. And again, bring it down, plus 1. Now, again, x divided by x, positive 1. First term together. So then x plus 1, and it's 0. So in this case, I can conclude that it's a perfect factor. The divisor is a factor of a dividend because the remainder is 0. So I would say x plus 1 is a factor of x cubic plus 1. Therefore, division statement would look like x cubic plus 1 is equal to x squared minus x plus 1, which is the quotient, times a divisor, and that's it, because plus 0 is the remainder. Now, this is a different type of question. So what is the polynomial function? You have to divide this given function to get a quotient, and we have a remainder. So this is not a specific long division question, as simple, but when you get a question like this, put it in a division statement. D at x is equal to q times divisor plus a remainder. And what I'm going to do is I'm going to plug everything in. So dividend, so 3x cubic minus x squared minus 2x plus 6, and a quotient, which is x squared plus 1. And we're looking for a divisor, which I'm going to put it as d of x, okay, and then plus negative 5x plus 7. We are going to isolate for d of x. So treat it as if this is like a one variable. So to do that, I'm going to move this to one side first. So 3x cubic minus x squared minus 2x plus 6. So it becomes minus negative 5x plus 7 equals x squared plus 1 times d of x. Now when you do this, simplify negative negative, negative positive, you get 3x squared, x cubic, minus x squared plus 3x minus 1. Now I'm going to divide both sides by x squared plus 1 to get rid of it. So let's divide both sides by x squared plus 1. This side as well, x squared plus 1, so that you cancel out. So this will be x squared plus 1. So when you get to this point, what we can do is we could actually divide a polynomial. So on the side, I'll be writing the dividend 3x cubic minus x squared plus 3x minus 1, x squared. I'm going to fill in 0x plus 1. So 3x cubic divided by x squared, it's going to be 3x. So I will be aligning with the same degree, 3x. 3x cubic plus 0x squared plus 3x. You subtract, so it cancels out. Then it will become negative x squared. It cancels out. So I'm going to bring the last one that's there, negative, so 0x, 0, minus 1. So this is supposed to be 0. Now, negative x squared divided by x squared will give me negative 1. So distributive property again, negative x squared plus negative 0x, and then minus 1. And they all cancel out. So we have a remainder of 0. So that tells you that it is it divides perfectly as a divisor. So therefore, we could conclude that the divisor is going to be equal to 3x minus 1. And that will fulfill this statement of a polynomial function. Now, so we feel very comfortable with long division, but now we're going to look at a synthetic division. So synthetic division is a shorthand method for dividing polynomial by a linear divisor. So this will only work if my divisor has a degree of 1. If it's not a degree of 1, then you will have to do a long division. Synthetic would not work. So the first one is you will be writing down your polynomial in terms of coefficient only. And you're going to find the 0 of your divisor. So in this case, you let x minus b equal to 0. So x is equal to b. Your divisor will be written over here with a line. And then so the first coefficient comes down. And then you're going to multiply b times a, which comes over here on the next column, and you're going to add as you move along. So let me show you an example so how you can apply this knowledge. So it says use a synthetic division to find the quotient and remainder. First thing, make sure that its divisor is linear, which is great. And the dividend, the degree has to come in decreasing order and don't skip any exponent. So 3, 2, 1, and 0. So now we're going to make a half rectangle and write the coefficient only. Negative 2 in order, 3, negative 4, and 5. Let's find the 0 for the divisor. So x minus 2 equals 0. X is equal to 2. So I'll be placing 2 over here. Let's do the synthetic. First step, the coefficient for the first term just comes down automatically. Negative 2. And you're going to multiply your divisor, 0, 2 times negative 2. Which will give you negative 4. And every time, this is opposite of long division. What you're going to do is you're going to add as you go column to column. So what that means is that you're going to do 3 plus negative 4, which will give me negative 1. Negative 1. Again, 2 times negative 1 will give me negative 2. And as you go down the column, you're going to add negative 4 plus negative 2, which is negative 6. Now, let's multiply the divisor zeros. 2 times negative 6 will give me negative 12. Add them up, which will be negative 7. Now, always the last number is going to be your remainder. Okay, so that will be the remainder of this synthetic division. And we are going to write all the dividend and divisor. So in this case, divisor, we already know is x minus 2. But the quotient is a coefficient, but 1 degree less. So because it starts with x cubic, this one is going to be x squared, x, and x to the 0. So this is going to be the quotient. So therefore, I can conclude that the quotient is going to be negative 2x squared minus x minus 6, because x to the 0 is 0. X to the 0 is 1. My apologies. And then the remainder is negative 7. So remainder is always going to be a constant, which is a number. Let's try again. So we're going to use a synthetic division, check that it's linear, which is x to the 1, and we can conclude that the 0 for my divisor, x is equal to negative 3. Now for this one, unfortunately, the dividend, it doesn't decrease, and it's missing x to the 4, x to the 2. So I could rewrite this as x to the 5 plus 0 x to the 4 plus 2x cubic plus 0x squared plus 0x and then minus 3. So it's very important that you fill in the missing information so that you're not skipping a degree. Okay, so let's half a rectangle. Let's write the coefficient. 1, 0, so it's 2, 0, 0, and negative 3. Let's extend it. So let's double check. Degree of 5, 4, 3, 2, 1, and 0. And my 0, in this case, negative 3. Now, the first term, as always, it just comes down automatically. 1. Negative 3 times 1 gives me negative 3. And then you're going to add vertically. 0 plus negative 3 gives me negative 3. Negative 3 times negative 3 is 9. You add them up, which is 11. 11 times negative 3 is negative 33. You add them up, negative 33. Negative 33 times negative 3 is 99. And then you add it up, 99. And 99 times negative 3 is going to be negative 297. And you add them up, it's going to be negative 300. Great. So last number I always label, this is going to be my remainder. And the quotient is 1 degree less. So if we started with x to the 5, that means this is x to the 4, x to the 3, x to the 2, x to the 1, and 0. We can conclude that remainder is negative 300, which is a constant. And the quotient is going to be 1 x to the 4 minus 3x to the cube plus 11x squared minus 33x and then plus 99. Okay, and that should be your final answer using a synthetic division.